Circle theorem. Nobody seems to understand this, so I made a video to fix that. Okay, let's talk about the different theorems like discussed in the chapter and in my notes. Okay, now firstly, this line is not the same. Okay, let's start. First theorem is angle subtended by diameter on circumference is 90 degrees. Okay, what does this mean? If we have a triangle whose diameter whose hypotenuse is the diameter of a circle, then the third point, okay, will be 90 degrees always. Okay, this works for a 90 degree angle, 90 degree thingy. If you excuse me, yes, I lost this point. Okay, do not lose yours. Okay, next is angle between tangent and radius is 90 degrees. This is straightforward and easy to understand. If we have a radius and we make a 90 degrees at it, okay, at this point, okay, then we will get a tangent. The tangent is always 90 degrees to the radius, okay, in anywhere of the circle. Okay, next is angle at the center is twice the angle at the circumference. Now, what does this mean? If we have, say, this angle 50.4, okay, or x in my notes, okay, and then if we move this third point, okay, that is being made by these 2 points right here to the side, you move this to the center, this angle will be doubled. Okay, now I do not know how to prove it, but trust the process. Okay, so it will be doubled always. Okay, if we find a cat ear shaped, okay, a cat ear shape, and this angle and the same 2 points which make the cat ear shape be connected to the center of the circle, then you will always have this. Okay, well, you need to draw new things to it and new lines and stuff to the diagram in IGCSE, but in O levels you don't generally have that. Okay, so this is the rule. Another thing is, for these cases, how do we deal with cases like these? Well, for this you need to know that when we have this rule applied, okay, angles at center is twice the angle at circumference, then the angles should be facing each in the same direction. Example, in this diagram and in the notes, the angles are facing downwards. Some diagrams may have it to the side, some diagrams may have it up, but it's generally the same. Okay, just rotate your answer question paper to see it. Okay, so that's the first thing. When we have this case where we need to find the angle at the center, but we have this, okay, this given, and how do you find it? Well, to find it, you need to first get the angle. No, you need to first get this one. Yeah, you see the angle 129.6. You first multiply it by 2. Okay, to have this reflex angle. Okay, reflex angle. I do not know how to have a reflex angle in this in Desmos. Okay, but this reflex angle, you calculated the reflex angle. Now we then calculate the remaining of this reflex angle, which is 360 minus this, which is the angle at the center, 108. Okay, and that's the correct answer then for that question. So how do we do this? Again, let me tell you, we have this angle, we double it. okay, to calculate this reflex angle. Then we calculate the remaining angle to find the angle that the question is asking for. This angle which is opposite to this given angle. Okay, let's move on. Angles in the same segment are equal. Now this effect also works in this diagram. Okay, if we see, but this is a more generalized diagram. Okay, with two, which is even better, with two cat ears. Okay, if you have a cat ear shape, okay, and if we go along the same arc, okay, then we will get the same cat ear shape every time. Okay, now now this rule has different names. Okay, called to it. Angles in the same segment are equals in my notes, or another name for it is angles subtended by the same arc are equal. Subtended by the same arc, what does that mean? So if we have a circle and have this cat ear shape, okay, subtended in cat ear shape made by the points A, B, C, okay, then if we go along the arc AXB, if we go along the arc AXB, then this will be always equals. Okay, if we get a protractor, then you can see that the two cat ears that I drew are same. Okay, and subsequently the angles in the same segment just means this area. It's just talking about the segment AXB. Okay, so this is the rule. Okay, if you have this, this will be always true. Same segment, same angle, same arc, same angle. Okay, but if you have this, what is this angle then relative to C? Well, we will talk about in the next. This is covered in the next diagram. That opposite angles in a quadrilateral sum to one. Whoa! What the hell? Wait. As I was saying, opposite angles of a cyclic quadrilateral sum to 180 degrees. Okay. Now, when two angles sum to 180 degrees, they are called supplementary angles. Okay. I have given A plus C is equals to 180, B plus D is equals to 180. And if we see from the values given in this by the Desmos, we see that this is true. 70.2 plus 109.8 is 180. 104.4 plus 75.6 is 180 as well. So this is true, and in this case this angle over here, angle ADB, will be 180 minus angle C, or in other words, D plus C is equals to 180. Okay, so if you have this case, and to find the other thingy, you can find it using this. So example question, if we are given this angle right here and we have to find the angle Z, so what do? We copy Y to here because of the two cat ears, cat ear shapes we did. How do we identify cat ear shapes? Well, one way is to now I cannot show you my fingers, but if you take your two fingers and place them at A and B, for example, and then go along the arc AXB, then you find which cat ear shapes do you see. Okay, cat ears are always by two lines. Yes, by two lines. Okay, so you can see how many cat ear shapes do you find. Okay, then you will know all of those cat ear shapes have the same angle made at their apex and their height, you know. And then when once you do that, then you can use the cyclic quadrilateral rule, which is this, and then find z like so. How do we identify cyclic quadrilaterals? Well, you just need to find any 4 points which are connected by one line. Okay, it's just, you know, looking at it carefully. Okay, if you cannot, because that's what you need to do, sadly, just look at the diagram carefully and realize that it's a cyclic quadrilateral. Okay, now some people will also say that, okay, they will be confused, and that is this a cyclic quadrilateral? No, this is not. Cyclic quadrilaterals always are made by points at the circumference. Okay, this is not a cyclic quadrilateral because it is not. Okay, it will always be if you have some sort of odd shape going on. Okay, it can be a trapezium, for example. It can be a normal rectangle, for example, any weird shape that you want. But this is not a cyclic quadrilateral. Okay, so that's one thing to keep in mind. See, it'll be like a trapezium, it'll be like a kite, it'll be like a rhombus, it'll be like a square, it'll be like a rectangle, but it will not be like this dart shape thingy, you know, arrowhead. Next rule, alternate segment theorem. Okay, for a tangent at one point of a triangle, exterior angle with the triangle is equals to the non-adjacent opposite interior angle. What does this mean? Okay, what now? If you have a triangle, okay, and the tangent at one of its points, then this angle and this angle will always be same. Okay, just trust me. I do not know how to prove it. Okay, I tried making this abomination. Okay, I won't be going into detail how this abomination is. I can't possibly prove this, but just trust me. If you have a triangle and a segment at a, and one of its points have a tangent to it, then it will always be having this rule applied to it. Now, if I just remove some of the goof yap in this, okay, then we can see this red, green and black thingy, that all of these add up to 180 degrees, and so does the angles inside this triangle. So you can identify it like that. Okay, one way to know that which angle to copy is if the angles are facing the same relative direction. Okay, so if I remove this details, okay, and see 71.3, these two angles are facing generally towards the left. Okay, these two are generally facing upwards. Okay, so this is how you can, you know, identify it. This is like another the practice thingy. Practice makes perfect, like the quadrilateral thingy. Well, you'll get used to it soon enough. Okay, next, these final three are, you know, very little to come by. These two especially, equal chords and the perpendicular bisector, these come in uh, the circle theorem too, where you can you use trigonometry with it. Okay, these two are equal, are easy to understand. If we have two chords AB and CD and they are said to be equal, of equal length, okay, that means they won't be perpendicular. Okay, but if they are equal lengths, then if we draw a radius OX, then the intersection will be at U. Okay, so OU will be this segment. Okay, and if we same do it for OV, if we draw a radius OY which intersects with CD, then the intersection will be at V, and so the segment OV will be the same. Why? Because it's the same distance. Okay, if we just take AB and just flip it around, you'll get CD. Okay, if CD was some different orientation, okay, then it will be just rotating AB about some angle to get CD thingy. Okay, so this is how this rule is. Okay, equal chords are equidistant from the center. Okay, I did not animate this diagram. Okay, I just did not have the brain power to do it. Okay, I was like tired after making these main ones. Okay, which people are confused about. Next is the perpendicular bisector of chord passes through the center. Okay, if we have a chord AB, for example, I did not label it in my notes. Okay, sorry. Then if we pass through a radius through it, okay, if we see this radius, it becomes dotted at the after the point, but trust me, if we have this, then it will always cut the cut the chord into two. Like example, if we draw a chord in this chord, okay, if we draw a radius to it, it will cut it into two equal halves. Okay, always. So you can use this in your advantage. If we have the length AB, then we know if we draw a perpendicular to it, we just have one of the sides half of AB, and then using the radius you can find this perpendicular this height, height segment. Final rule: tangents from an external point are equal in length. AT is equals to BT and angle O plus angle T is equals to 180. Now this is somewhat easy to prove. Okay, if we see, we can just use we can prove it using congruent triangles. Proving it is like out of syllabus, but I will still do it. Okay, now we see that OA and OB are equals. That's one side. Angle A, angle B are 90 degrees. That's 2. Angle AOT and BOT are equals because the angle AOB is just bisected by the line OT, so they should be equals. Okay, like the angle is cut into two equal halves, so obviously they should be equal. So this is how you can prove this. Okay, I did not go into hassle of drawing it because it's out of syllabus, but you can imagine that as your explanation. Okay, so these are all the rules in circle theorem. Okay, and I hope this video helped you understand this God forbidden chapter in your O levels journey. Okay, goodbye.